So here's the before, and here's sort of the after that we want. Instead of this, right, I want the same thing, but we don't write pickup type underscore anymore. We just do that. And these will live in the namespace of pickup type. And then enum will just be one kind of namespace, and eventually we will we'll add other ones and or factor them to share the same data structure. So anyone who uses this for now can use this. Pickup type dot. Yes, 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 yes. Okay. Now that looks like mainly a cosmetic change, and for now it is, but eventually, you'll be able to say something like, using pickup type, right, or using pickup type as PT or whatever if you want to make things shorter. But first things first, we just have to make this work at all. So let me convert also. We're going to have to convert everything. So let's just do that. Let's just go whole hog, right? So this has got to be shot type. Later here, yeah, see this is a lot of typing of shot type. So later here I would probably say using shot type inside this function. Let's go to C++ mode. Make it a little more readable. So this looks like I'm just adding more verbiage into the program, but the advantage is just as the program gets bigger, as programs get bigger, you tend to have to like put more stuff on your enum to make it more specific what you're talking about and to avoid conflicting with other stuff, and we won't have to do that because it'll just all live in shot type. And again, here I could just say, using shot type, and that'll factor in. However, we won't implement that yet. We want the most simple version, which is just going to be this. So let's see if there's any other enums here. No, but there are some in the libraries. So I'm going to be, basically, I'm kind of committing myself to this feature because nothing is going to compile. Because I'm not just breaking this program, I'm breaking all this stuff. So instead of optimization debug and optimization release, I can say debug and release. And yeah, so here instead of saying argument type here everywhere, I'm going to go argument type gets replaced with, see how much nicer that is? See how much nicer that is? I don't have a checks. All right. So yeah, nothing's going to compile until this works. Oh, and GL. OpenGL. I'm not using enums for these though. I'm using them here. Event type dot key underscore with nothing. Yep. Key code dot unknown. Okay. So I probably made a mistake somewhere, but it strikes me just looking at this that when I get to having first class types, this is an inconsistent notation. Because if this enum event type, for example, is its own type, and I could make something else the same as event type, then this is actually a thing containing all these enums. So saying that this is an event type is not true. like it should be like member of an event type. I don't want to deal with that right now. Oh no, maybe that's not true because yeah, that's actually not true. When we go to first class types, we'll need some kind of prefix onto the thing. Yeah, it's fine. There's no real problem. Can't see the bottom of the editor. That's what I get for streaming at high res. You know what? Here, I'm going to change my screen resolution so that you guys don't have to squint. Okay. I don't want you to have to squint. I'll keep that big. All right. Yeah, what do you mean by annotations? Because annotation can mean a lot of different things. A lot of different things. It's a very generic word. Okay. Well, before we actually implement the ability to do this, let's see what happens. It'll probably complain. Undeclared identifier of like shot type or event type or something. Yep. Oh, well. Wait, supposedly that's a weird it's a weird error message, but it's probably not the most helpful error message, but it's not my job to clarify error messages right now. So I'll worry about that later. One thing at a time. First, let's make the compiler work, and then we'll make the error messages good. Yeah, so I kind of don't know why it says wanted enum got a number. That's weird. It's all weird. It's all weird. Okay, so let's, as always, go to a really simple program now. Well, do I have one in? No. So we just make it work in a really simple program. Oh, this is our old one, our old friend. I'm actually going to save this as initializer test. That's what I was doing on the last stream. And I'm going to add that to source control, because I can clean that up and make it into a test and make that into a regression test where I diff that and whatever. Okay. So we're basically going to delete all this, though. What are we going to delete? Yeah, let's just delete the whole file. We're going to say main, and we're going to say hello is an enum with alpha, beta, 1, gamma. Well, it's not gamma. Okay, printf alpha is you know what? Just that. Okay. Testing, yeah. Sorry, yeah, my USB plug that this is plugged into is like a weird, shallow USB plug, and if I tug onto it even a little bit, then it gets disconnected. I'm just waiting to see that, just make sure it got fixed. All right. Someday after the witness ships, I'll buy a new computer with better USB ports on the front. Okay, so basically all I was saying is this is what we want to work here, right? So right now what's happening according to the old semantics is alpha, beta, and gamma are getting dumped into the global namespace, right? And so if we were to delete this, hello, this should actually compile and work, except it won't because like we messed with the basic and GL modules, and I don't want to go and make them all wrong just for this to compile. So, and we need basic in order to have printf. Although actually, okay, here. I'm going to go here. I'm going to find printf. I'm going to come back here. We're not going to import basic. We're just going to declare that there exists a printf that's foreign, and then we're just going to do this. So in theory that... I freaking Emacs. All right. I put this in the wrong file. I want this to be in mini. I want this to be in initializer test. All right. So this is mini. Okay. It still says identifier not found. I'm not sure. Oh, that's in C. Right, the C version isn't going to compile because we're not including basic, which includes the C library and header files, but haha, let's do this. This should work in the bytecode. There we go, alpha 0. Beta is 1. Gamma is 2. There we go. So in C it's not working because again I'm overriding, I'm not including the place that actually links printf because of this hack. But in the bytecode it's working, and that's good. I always like to start from a working baseline before I go and do something weird. All right. So now let's change to what we want to compile. There. Supposedly constant declaration of hello is not a constant. I don't know why it says that. Let me just look at that for a second. And why is this on the left? Visual Studio, you're so crazy. All right. No, don't break there. These are all old breakpoints. Okay. So why do we think this? Oh. Right. Else if so basically this clause down here is just for numbers and strings and literal types and stuff, and you can declare anything as constant. So right now I'm going to put in a specific case for enum here. But I think that all the other cases besides constants are just going to look exactly the same. And so maybe it's like if it doesn't eval the literal, well, actually, yeah. So the reason this is here is right now, at global scope, you could put an expression on the right-hand side. Like, you could say define A as 2 times 3. And right now, we actually don't do like constant folding of that kind of expression. You could do that with the hash run thing. You could just say run 2 times 3, but that's overkill. But if you say 2 times 3, we'll hit this error, right? And so I never went and said, oh, an enum is something like 2 times 3. Or is not something like 2 times 3. All right, so here's the actual legitimate error. Attempt to dereference a non-struct, which is what makes sense, right? So line 12, it's basically saying, hey, hello is not a struct, so what are you doing? Which makes sense. So now we want to say, well, yeah, it's not a struct, but it's a different thing. Attempt to dereference a non-struct. Zoom in on this. Okay. I'm going to call this a non-namespaced type. See, the thing is, as your language becomes more general, your error messages have to be more generally worded, which makes your error messages worse and worse. So that's a different thing you have to fight. But like I said, I'm not worried too much about good error messages yet because there's no users of this language besides me. So oops. So, oh wait, what? Okay, so here's my type definition again, and one of the things it can be is a struct, and if so, that's set not to null. Like I said before, this should all be a union, but I just want to keep things simple right now, so I'm just hogging all this memory. So there's an enum desk, so I can just say, hey, if it's not a struct and it's not an enum. Now, eventually, I might make an enum and a struct like the same thing because, like I said, I'm adding namespaces, but what adding namespaces really might entail is unifying all these things under the concept of a namespace. So an enum might just be a keyword for saying create a namespace, but it's only got numbers in it and they're all const, right? And a struct might be create a namespace, but have whatever special properties a struct has, which might end up not being anything different from a namespace, a general namespace. That's going to be my goal. Okay, but for now, we're just going to make enums dereferenceable. So if it's a struct desk, we do this. What's going on? Why didn't that indent? Emacs has bugs. So I have to revisit the file. I have to go to line. See, Emacs. All right. So if it's a struct, we look up the declaration for the thing. Now, really, if it's an enum, it's the same. If it's an enum, we want to find the declaration within the enum, but I don't want to duplicate code. I want to make them into the same thing. So let me see. Find declaration within struct. What does that do? It grabs this thing called the scope, and yeah. And it's just this very slow linear search. We don't hash table anything yet or something, and that's because we don't have speed problems with the compiler yet. We eventually will. Let me change this to just find declaration within scope. Right, and then again, you have to change that in the header file because I don't, because Bjarne Strostrup doesn't understand what's important. All right, so within scope, all right, so for now, I'm actually not going to make these be quite the same thing. Eventually, a struct desc and an enum desc may become the same thing. But for now, I'm just going to do parallel code and see how it works out and whether the code ends up very similar or different, right? So I'm going to say potential future refactor should struct desc and enum desc become the same thing. Too early to know yet. Me, 11 November 2014. Okay. So I'm going to put a scope on an enum, which it doesn't currently have. And yeah, this is basically the same as the block above it. So these cut and paste markers tell me when I'm in the mood to clean up the code, I look for these and see if the code that I pasted at one time is still pretty much the same. And if it is, then I factor things together. I don't believe in doing that work up front because often you have to then undo it or the work slows you down. So, or you can do it, but you end up in a more convoluted structure because you don't understand the problem yet. Usually when you're first solving a problem, you don't really understand it yet. It's like after you've got it working and then you fix some things you don't like about how it worked and then it works smoothly, then you understand the problem well enough to build the real abstraction, which is why I don't, in programming school they tell you factor everything together immediately all the time, and I don't agree. All right, so I need to put in its scope on enums. Whoops, wrong header file. So let's put well, we almost have a scope. An enum gets a list of its own declarations. So I'm just going to put a scope on it, and the declarations are going to go in the scope instead of, so like it's, yeah. All right. Sorry, this is called ast block. Find declaration within scope. Within scope. Who's giving it one argument? Line 598. That's this line. I'm giving it 2 arguments, sir. Or ma'am. Like what? Oh, it might be getting confused. I don't know. Yeah, now Visual Studio is giving me bad error messages. Right? Find declaration within scope. Oh, right. I didn't. Yeah, okay, it's clear what's going on. What's going on is I'm sleepy again. I should do these streams in the morning sometime when I'm not sleepy. So declaration struct desc scope, right? And declaration enum desc. Oh, inferred type. Oh wait, I already have that. This is how tired I am. See, I'm trying to figure this out right here, and I'm not even looking at this right here. Like, that's what I want. Because I cached this into that. Yeah, I'm going to have to do a stream someday when I'm not tired and distracted. And it would be good to show people, like, when I actually, yeah. So we'll lift this out. Declaration is null. And then if we got down here, we'll assert declaration because it means we should have passed either of those. All right. So now this compiles. It's still not going to work because I put a scope on enum, but I'm not putting anything in that scope, so it still should complain. Yeah, but we get a different complaint now, right? So now it's giving me undeclared identifier in enum alpha, which is good because it knows that it can look in an enum now. I just can't find that right thing. So now we go into parser. There's this declarations thing, and I'm going to move that into scope. Why am I going to move these into scope rather than just leaving them here and just looking them up in enum instead of on a scope? Well, I'm trying to unify the way everything's stored, right? So if enum stores all his declarations in a scope, and struct desc stores all his declarations in a scope, it's easier to go one step further and unify them further. Or just you have a more general namespace system, but you pass a scope around, right? You don't want to have all these special case, oh, we're storing things different ways for different types. So I'm going to look for where I add, okay. So this is interesting. So right here, I add to my declarations list, and I also add to the global, or the current scope where the enum is being defined, which usually is global. So I'm not going to do either of these. And I'm going to delete these comments. So whenever I change code, I often leave it as a comment for a while, and then I'll delete it later. It makes it easier to back up without going into source control and coming out all the time. All right, so I'm going to say checked add to scope. Checked add to scope looks to see if there's something of the same name in that scope already and gives you an error because you don't want to redeclare identifiers. And enum scope decal, right? So not and enum and ask. So enum is a keyword in C++, right? And so that's what I want to call my variable, but I can't. So it's a little bit awkward. It's a pitfall of, all right, well, it's still not working. Yeah. So I don't know why, because that maybe should have worked. So now I'm going to set a breakpoint here and see why it didn't work. First, let's make sure we hit that, which we do. The declaration is for alpha. And let's look at asked enum scope. Bunch of zeros. Members, there are no members. That's no good. All right, let's see what, okay, we've got beta. Why is beta not getting added? It's not a lambda. It's not redeclared. Oh my God. So this is a casualty of code factoring. Down here, it's always adding things. There's like a scope stack of what scope we're operating in. And right now, this is always adding things to that scope stack. But it's ignoring the parameter that came in. Oh, sorry, someone's texting me. iPad, please be quiet. Yeah. So this would appear to be a bug. This should say scope. Let me go into my editor. I'm much more comfortable in Emacs, like editing code. So here's what I just changed. I want to scrub, since I made that mistake once a while ago, I might have made the mistake multiple times. So I want to look for current AST block, and it doesn't occur in that function anymore. Okay, so that's good. All right. Well, now we get an assert. The assert is probably that bytecode doesn't like that there's a scope without a size. Like the scope is probably not getting any storage allocated to it. Let's see. It shouldn't, because everything in it is constant. But let's find out. What are you complaining about? Oh, okay. This is another. Right, remember when I did that literal thing and I said, "Oh, lambdas are the only thing that I dealt with." Well, enums as well, right? So if I look at decal inferred type, it should be an enum. Yep, it's an enum desc, and we be saying. So what are we doing here? Emitting code for an identifier. So what's happening is when we're dereferencing this namespace, so what's happening is we've made the code know that it can dereference an enum. However, that's only happening during type checking, and now when it goes to code generate, it's generating the same code that it would generate for a struct, which for a struct involves looking a member variable up in a physical struct in a pointer, right? And we don't want to do that here. We want to catch it before it goes to code generation. Now this also means, because these are all const declarations, it also means that if there was a const declaration in a struct, we were not actually treating it as const, we were generating code for it, which is fine because I'm not too worried about code optimization, but it's an interesting side effect that we may get that optimization. So because these members don't actually exist in any kind of storage, then we want to, sometime at code generation, fix it up. So the question is, when do we do it? The other day when I did when I decided to add const variables at all, so like you define something to 0 and it's const, which means you shouldn't have to look it up at runtime, it's like always 0 or whatever value. I did that by substituting directly into the code, right? Like anytime you use that identifier, I looked it up. I believe the same should be true for this. Like I feel like the right thing to do is if you use an enum like this, we should sub it in as a constant as early in the pipeline as possible. In the same place. Let me see if that's messy. Okay, so here's the thing. If we're looking up an identifier and it's a constant, then we just directly substitute it. Boom. right? And here's that thing that I just did for an enum. So on the left, if we say in our example, hello.alpha, it's actually replacing this on the left with an enum directly, which honestly speaking is, well, it's at least okay, it's inferring it. It's not actually replacing it. Which is fine. So we need an analogous thing to this when we do dot. So here's where we're doing dot. It's a binary operation. If the thing on the right is an identifier, then we grab the identifier, right? And we insist that we have that, otherwise this is no good, because we don't have member function calls right now. And even if we did, they'd probably start with an identifier. But we might not parse it that way. So here's what we do to dereference a struct member and type check it and all that, right? So we look up the declaration. Here's our thing that looks up the enum declaration, right? Okay, so this is all fine. This is the extra code that we just added. Normally what we do then is we infer types on both sides, and then we just say the expression that we return is dot of these things, a dot b, right? But I don't want to do that. If the declaration is constant, let me look up that flag. So if it's constant, I want to do one thing. Else, I want to do this other thing that involves eventually generating code for it. And what I want to do is exactly the same sub-in that I do for the identifier. And so really I want to factor all of this into a function so I don't have to, copy this or replace semantics. I want to say do substitute, well, let's say expression replacement. I want to call a function that either infers on the expression and leaves it alone, or looks up or gives me back the constant thing and tells me to replace it, right? So I want to say, and I'm gonna put this out here actually. Find replacement for expression well, I'm just going to say find constant replacement. That's more descriptive. Find constant replacement. If replacement, then and I know this is going to go into a function, so return literal. By the way, I described this in one of my lectures. What I'm doing is I'm taking something that was an inline block and I'm factoring it out into a function, right? So I'm doing that piece by piece. Right? So I'm going to say void code manager find constant replacement as declaration decal. And usually when I factor stuff out, I change my mind about how things should go. Like this might have been a small block, but now that it's a big block, I don't like all this indentation, and I don't need to do anything if it's not constant. So if it's not constant, just return, and then we don't need all this indentation, right? Boom. So I need an asked expression here. So we're going to infer and return no replacement, yes replacement. What is this comment? If type is pre-declared, then don't copy the literal, just use it. Yeah, we'll leave that for now. All right, so we're calling find constant replacement. That all looks fine. Because we're in tedium land, we need to add this to the header file. And the more that I start working on my own language, the less I start trying to keep my C++ header files neat, because I just have contempt for them. They're stupid and they're a waste of my time. Must return a value. I missed one. Oh yeah, return null, no replacement, and ident, undeclared identifier. Ident should be decal identifier from. This is, remember in that talk I said, oh, sometimes when I factor something out, I don't realize what all the parameters needed to be. That's exactly what's going on. Let's pass the ident as well. And I have to do that in the header file. That's a total waste of my time. All right. I missed another value return. This is what's good about when a compiler isn't reliable, though, because I don't have to worry about when I make that class of mistake. It just tells me. All right, so our program still should not work because we haven't made the dot call use this. But I want to make sure that I haven't introduced new problems. Yeah. Well, let's see what that is. What is this? Oh, it's a null definition. Emit code for procedure call. Oh, I probably did break something. That's bad news. Let's just step through that and watch it work. So this is what, things were in a non-working state in the middle, so I'm not sure if they're still sort of in the same non-working state and I jiggled it a little bit, or if I broke something that worked. Actually, I should see what line number in the source code is doing this. Expression line number, expression file name. So line 12 of mini. Oh, it's probably just this still. So we probably didn't break anything new. So let's use this. Oh, right. Okay, I changed this here, which is why we've got a different error now, because we didn't infer on the declaration and stuff. So if it's a constant, wait, I don't need to check if it's a constant, because I do that up here. I say asked expression replacement equals find constant replacement declaration, comma, ident, if replacement, else, blah, blah, blah. So now, yes. So, last time we just replaced the expression pointer, and so we do the same thing here. So if it's if we're saying a dot b and it's a constant, then we drop it in here. Otherwise, we leave it for runtime evaluation. Maybe it'll work. Unlikely, but maybe. Oh. Hey, look, it worked. Alpha 0, beta is 1, gamma is 2. It doesn't work in C yet. Well, it probably will work in C. If I put this back and get rid of my printf hack. All right. Hey. All right, so that's our first step toward general namespaces, is that enums are now in their own namespace, and I don't appear to have made any mistakes in the modules and stuff. So let me go make another tea and take a 5-minute break, and then I'll come back and actually pay attention to the chat and see if people have questions, and then maybe I'll go on to step 2 of this. Enums are now in their own namespaces. Which means I could probably do nested enums now. Maybe. Oh, no, because the enum parser is a special thing. We don't want to do... Nested enum is ill-defined. We don't want to do that anyway. Okay, 3 to 5 minute break. Be back soon. I wish I had cupcakes, but I don't, and the store is closed. Okay. So what's up? What are people thinking in chat? I'll talk for a second while any questions scroll in. I'm not sure what step to do now. I want to do at least a little bit of work toward the next step, but I'm a little bit indecisive about what that should be. The runtime evaluation of code. Does it operate exclusively on sharing the same data type representation of the host? No, it doesn't matter. Sorry, the Twitch chat is terrible. This keeps scrolling off. Can you do a compile time endianness check? Well, we would probably make a compiler variable that you check for what's the endianness of the target platform would be the real way to do that. I wouldn't like run code at compile time that checks the endianness of your numbers. That's inappropriate. If you're planning to use that on the target platform. With respect to namespace, do you think binary namespaces would be a good idea where some prefix? No. Okay, here's the thing about namespaces, and this gets into what I'm talking about next. If you're using, if part of the point of namespaces is that libraries are in a namespace and stuff, the library should not get to name the namespace. You should get to name the namespace, right? Like the library should just consider itself global or whatever, right? And you get to use it and encapsulate it in whatever name that you want. So you don't need an ABI with namespaces on the library unless the library has its own internal namespaces that it wants to use, right? So if I'm going to import something, this is a very temporary thing, but I eventually want to be saying stuff like import basic 1.2.1 as foo, right? And then that all goes into this namespace foo. It doesn't go into a namespace basic, and then I have this versioning and stuff. So yeah. How's the New York talk going? Good. It's a game design talk, so it's a little different from what I'm talking about now. When I release the witness, am I going to put all my future games on hold until this language project is done? Maybe not completely on hold, but this will probably become my main project after the witness ships, and then any other game that I do might become the side project that I do in my off time. Can the compile time functions get information about the piece of code they're acting on, like say the return type and parameters of a method? Not yet, but that will happen eventually. Eventually you'll be able to introspect the whole program and possibly be able to modify it or not, depending on if we decide that's a good idea. Just how close do you think the enums and structs can be given the different usage? Like enums have no member pointers. I don't see why that matters. An enum is basically a struct with all static integer members, right? So why not, for all language semantic purposes, just treat it as a struct with all static integer members, or all const integer members, right? That simplifies things a lot. I'm not doing that right now, because the enum and the struct that I started with were just to get the language going. But as I figure out how things should really be, things may get combined or whatever. Mentioned earlier that the errors are bad, but it's not a concern in a moment because it's early. Is there anything you have to do upfront in the language design to ensure that you'll be able to generate good errors, or do you think that good error messages are something you can add at the end? Well, you've got to design the compiler to at least get you in the neighborhood of good errors, right? So, for example, um, on every expression, I tag it with what file and line number that expression is from, which sounds simple, and pretty much every modern compiler does that, but old compilers sometimes didn't necessarily do that. So they gave less good error messages. Um, and then it becomes, at some point, it becomes a case by case basis where in some part of the code you just might have to put in some extra work so that that piece of the code knows more about the context. So one example of that right now is if I'm passing arguments to a function and one of them, the type is wrong, then the error right now is just going to say type mismatch at line whatever, character whatever, right? And if I wanted to make that better, I could print out the line and put an arrow to it, right? But the code still doesn't know, oh, that error is in argument 3 or whatever. And it would be nice if it would say argument 3. And to do that, I just have to provide more context to either the error reporting function, or I need to check if an error was reported, and then on return, the argument person says, oh, by the way, that was in argument 3, after the error message. I don't know. There's lots of ways you could imagine doing that, and none of them are hard, provided that the core structure of the compiler is kind of decent. So that's where things are at. For any case of an error message that's bad right now, I look at it and I'm like, yeah, I don't love that error message, but I have an immediate path to making it better if I want to put that effort in, and I just don't right now. If only because by the time I do, and by the time there are going to be more users of the compiler, there might be a better way to do that stuff. The structure may have changed enough that some other way of doing it becomes clear. So I don't want to, I'm lazily evaluating my error message implementations. Any plans on giving stricter requirements for data type representations? For example, 2's complement greater than all. I don't know what that means. Yeah, languages leave these things implementation defined, leading to underflow, overflow. Oh no, I think probably numbers are defined as 2's complement, and if you ever run this on a CPU that isn't, then maybe it's not fully compliant, and maybe that's okay. It'd be interesting if the ask checking code could check whether you have called OpenGL commands in the right order. Yes, I agree. OpenGL is a giant pain in the ass. You can't always know, even from the abstract syntax tree of your program, whether things are called in the right order, though, because sometimes stuff is spread across multiple functions and whatever. But you could do what you can, right? That's part of the idea behind doing error checking this way with program inspection is, you can't always catch all the errors, but maybe you can catch a bunch of them in ways that a formalized type system would not be able to, without requiring you to do crazy things. Anything that you can think of where C++ gets in the way of something that game programs commonly do? Well, C++ is, once you start using templates and things, it's horrible in the debugger. It's hard to see what your program's doing. Error messages start getting bad. And, the C++ community is trying to clean up the error messages, but I don't feel like the debugging situation is going to improve ever for that language. But also just the higher level things that you do in C++. None of them are good. Well, not none of them, but I'm not going to rant about C++. I'm not going to get started. I've done enough ranting about C++ in my videos. Why am I still using fixed function GL? Because I wanted to get stuff on the screen. GL is really hard to deal with now. And it's very easy to make mistakes, especially if you're using GL3 or something. And so the point right now was just to get some spaceships on the screen for my little 2D game. And to do that, I didn't need anything besides fixed function pipeline. as I migrate that to trying to be a more respectable GL interface module that other people can use, it'll have all of GL in it, right? And people can use anything. It's just for my demo program, and like I'm working on a compiler, I'm not working on a 3D game here. So yeah. Goes IOTA keyword. I don't like IOTA is the thing that increments. I don't love it. Like I don't see why you really need it, honestly. But like I just read about IOTA the other day, and I was like, oh, that's interesting, I guess. So I'm going to keep an eye out as I write code and see if there are cases when I'm like, oh, I could really use an IOTA here. But I don't feel like it's a very common thing, actually. People are landing a robot on a comet right now. Any plans to add binary notation? I don't know. Comet landing. Wow. All right. Too bad they don't have a live stream of the control room for the comet landing. Am I manually exposing C functions, or does the compiler understand C interfaces? I'm using something called dynecall. You can go to dynecall.org, I think is the website. Checking that. Yeah, let me type that into the chat. So you can go there, and there's a library there that actually does that for you across many platforms. So that was very nice. I didn't have to do the interfacing with C myself. It was provided, and that sped up development of this part of the compiler tremendously. Any plans on supporting recompilation without restarting application? Yes, not for a little bit, but yes, I definitely want to do that. Comet landing live stream. Any development on the memory pool syntax? Someone is asking. No, that'll happen, or something will happen. I have something bigger and possibly much stronger that I want to do first. So that memory pool thing is going to happen later. What I'm going to do first is more like what inheritance should be in this language. These people in the comet landing thing are standing in front of a really goofy backdrop. Oh. Am I at the point in language development where the thought of how to integrate scripting languages has come up? No, that will not be for a long time. But the first step toward that, and doing a better job integrating scripting languages than C++ does, is providing much better introspection of your program's data structures and possibly the code. Because a lot of the grunt work of hooking in a scripting language is like integrating with your data structures. And if you can automate that, then it becomes much easier. Will I add the ability to interactively script? Maybe. I don't know. Right now, I'm looking at the compile time evaluation as a separate and clean thing from the runtime evaluation. I don't know if I want to get into like JIT land and stuff because, functional language people are big on, having eval and apply and stuff like that. And honestly, I don't find that I need that stuff in my day-to-day life. The only reason I would want it is to have edit and continue style functionality, which I believe can be built a different way. So I don't know why I want to compile a function at runtime necessarily, unless it's a shader. I don't know. I mean, possibly once you get a more powerful language and all your old problems go away, maybe you get new problems, and one of those problems is, I wish I could compile this at runtime. But As I'm like I said in the first talk, I'm trying to avoid big ideas, right? Big ideas that sound cool but that aren't necessarily useful, and I'm trying to focus all my effort on things that I know that I can use effectively today, right? And so I'm skipping that kind of thing. Where is support of coroutines in the lists? Somewhere, I don't know. What about extending enums, something like this? I don't understand what you mean by extending enums. Sorry about all this weird back scratching I'm doing today. I have an occasional neck injury and it really is paining me today. I don't know what happened. It's probably that bad fight with that rock monster made me tense up and aggravate my neck. It would be great if an application written in this language could also run scripts at runtime. It seems unnecessary to code in different. Yeah, maybe, but you have to remember my audience for this is professional game programmers and other people who want to write really low level stuff. Like, we don't necessarily want to boot up an interpreter that runs interpreted code necessarily. If we really end up liking the language and we want to do that, we might find that a convenient thing to do later. And you certainly could link the compile. Like, I'm going to talk about how to do that and stuff, and you can do it. But I don't think of it right now as a core defining feature of the language that's going to make everybody love it and jump on it. The things that are going to make people love it and jump on it are more fundamental than that. Thoughts on generics slash templates? They'll happen, but they'll be better than C++'s. We'll go into the details later. What do I expect to be the most painful, sloggy part to implement? Just all the little bugs? I don't know. All right. Enough questions. Let's talk about doing a little more work before I get too tired and neck injuried. Actually, I'm going to take a 2 or 3 minute neck injury break. I will be back. well. We'll see if that helps. Well, the number one thing that can make generics here better than C++ is not have C++ generics are essentially macros, all right? Which means you have to include an include file to use them, and they get pasted into your program in a weird way, and blah blah blah. So the first step is they're not macros. And also having to say like template type name t everywhere in front of every function and whatever is just hideous. I don't think this language will have lazy evaluation in it. It's just not the kind of feature. I may do partial evaluation of functions because that's easy once you have closures. But all right, so it occurs to me that the feature that I should have now is using. So I'm going to say delta here. And I want to say using hello. That'll be the first step. And then I also eventually want to be able to say using hello.delta and just grab that one thing. So I don't know. I'm kind of tired at this point, so I don't know if I'm going to get all the way through this, but I'm going to get a little bit through it. Lazy programmers. Not lazy evaluation. All right, so this is always fun. Adding a new keyword is always fun. Or did I add using already? Because I knew I'd do using eventually. Yep, I have a using. It just doesn't do anything. So here's a keyword in my giant not efficient keyword string comp table. And what am I going to do with it? It's going to be a top level. Well, no, it's a statement level declaration. Is it a declaration? I don't think it's a declaration. It's a thing that let me see if I can just shoehorn this into the parsing structure somewhere. Parse top level, parse one top level item. Compiler directive declaration. Yeah. Okay, well. So the thing is, we want this to work at top level and at statement level. So what we'll do is we'll look for using if token type, and we'll just call off to somewhere. Using really kind of should work everywhere. Well, anywhere statement level or above. It should not work as an expression. Well, it should, but that'll be a different trick that I'll save for later. Okay, so if we have a keyword using, then we're going to parse using return, right? So can we return null here? Who calls parse top level? That is called by it wants us to return something. I could explicitly return a done. No, I'm going to return a dummy thing. So parse using return interp type def void. This is just kind of a hack so that we have returned something non-null. Not the greatest, whatever. Okay. Parse using. We peek at the next token. We assert that it's using because we shouldn't have got here. We eat the token. Now, what I'm going to do on the RHS is parse any expression. So, usually if people define a grammar, they would say, okay, using, and then the thing that you can use has to be a sequence of, well, maybe I should do that. No. No. It doesn't matter. So instead of making it a special grammatic thing, I'm going to parse any expression, and then I'm going to reject the expression if it's invalid. So I'm going to say expression RHS, right-hand side is parse expression. Yeah, so I don't need any arguments there. If we didn't get it, then we already will have reported an error, so we don't need to report an error. I wonder, somewhere out there in the world, some C++ zealot is watching me type this stuff, and he's like freaking out because I'm using bear pointers everywhere. Oh my God, he's typing star. It's terrible. Okay, if we got an expression. Oh, well, here's the thing. Maybe I do want to parse it specially because, yeah, I do. Well, no, I don't, because we're parsing. Okay. Here's the thing. I can either parse an expression, in which case it's going to be a tree of dot references, because you could reference through multiple namespaces, right? You could go like a.b.c.d, and that should be in this left justified tree, and if it's not left justified, you assert. But remember, this is not like C++, where all those things will be defined when I read this using. When I read this using, I might not have loaded the things that I'm using yet, right? Because symbols can happen in any order. So, what I need to do is add dependencies. I need to make a new thing called a using. And that doesn't actually, it's not going to generate any code eventually, but it'll last through the type inference phase, and just before bytecode generation, we will, no, not even just before bytecode generation, in the middle, yeah. So as soon as bird and as soon as all its identifiers are resolved, then we activate it and pull the namespaces in, right? Which means, okay, here's the thing. So the problem statement is sort of this. We can say using a.b.c.d.e, right? Or something like that. Now, we don't need to worry about resolving B, C, D, and E until A gets resolved. So really, we can just store an array of these guys. And because array pushing and popping, it's easy to remove the last element, right, without reallocating your array or reordering it. Because it's slow. If you have an array that's A, B, C, D, E, like I want to work my way left to right in this array. Like don't do anything till you get A. Then when you get A, eat A and work on B, right? Since that's slow to do that to an array, I actually want to store these as E, D, C, B, A, which is going to be natural when my parsed expression is like this. It's going to be like D dot E. Wait, it's hard to think backwards. Well, let's say it's E dot, no. Okay, A dot B dot C dot D dot E will be A dot B dot C dot D dot E. That's going to be like what the parse tree is like. So there's going to be a node with a dot and an E on the right and all this on the left, right? And then on the left there will be D and then all that. And so actually the order we store this in the array is going to be the depth first order that we visit this in. So I do want to parse it as an expression and then get that stuff back. So that's interesting. I don't know if anyone followed that, but yeah. Why not just use a linked list? Because linked lists have very bad memory locality properties, and they're actually very slow. You really want to use an array if you can help it. Especially if you want your compiler to be really fast, which we will eventually, right? And I'm doing some things that are not that fast, like hey, I'm putting all these functions in just a list and we're stir-comping them, but or all these identifier names, right? But that is relatively easy to optimize. If I use linked lists now, I'm just making it a pain in the ass to switch off linked lists later. So I'm using arrays now because that's just what you want. Small fixed size arrays for speed. Okay. Let me define. Well, let me not forget to do this first of all. In fact, parse using is not going to return anything. You got to do this, or C++ will complain. And then I want to declare what this is. So let's go to where all my stuff is. We'll put it before the compiler directives. And after enum is sort of the last thing I did, so we'll do struct asked using public asked expression asked using C++ zealots will also freak out at the way that I do this. So we're going to go an array of asked identifiers. So that's going to be that A, B, C, D, E thing that I just talked about. And I'm going to say, what do I want to store? Do I want to store the scope? Yes. I'm going to say asked block current scope equals null. So as I pop things off the identifiers and resolve them, I'll put them in current scope, blah, blah, blah. I lied. We do want to return something from here. We want to return an asked declaration because we need declarations like the things that flow through the dependency system of this programming language, like the identifier lookup and resolution and stuff, are declarations. So I need that. So first I need a type called asked using. This is my type tag that goes in the first word of the struct. And what did I just say? Oh, I need a declaration. So parse using returns a declaration. Let's see if that compiles. Not totally. Oh, semicolon. All right, yeah, I knew that. Not all control paths return a value. Bunch of warnings I should fix someday. All right. Not all control paths return a value because I didn't do anything here. So let's go ahead and do it. Auto decl is ask new, ask declaration, decl expression equals ask using return decl. Using won't have an identifier. Well, actually, so we want to do this stuff before parsing the expression, and I'll tell you why in a second. So auto asked using equals asked new, asked using, which is the thing I just defined. Okay, so this asked new macro, whoops, it allocates memory for this, but it also fills in the file and line number based on where I am. You know, it asks the lexer, where are we in the file? And so I want to do this before I parse the expression, because in the middle of the expression, you might generate an error message and you might say, oh, it's in the middle of this one declaration. Now, I also do a push declaration, although I guess I'm not using that anymore. Wow, do I not use all this stuff? Whoa. Maybe I can just delete that code, but no. Okay, scope push handler, that's what I do, right? So this is sort of like, you know, I showed that defer statement that I've added to this language. Anytime you want to do something like that in C++, you can make a class with a constructor and destructor. So what I want to do is I want to push a declaration onto this declaration stack so that error messages know what declaration we're in and stuff. Or not just error messages, but dependencies. Because when I say using A, B, C, D, E, and C is not loaded yet, we need to know that this using should be processed when C gets loaded, right? So we need a dependency between using and C. And so when I parse this identifier C, I need to know who the dependency goes on, right? And so we use this declaration stack for that. So I need to push the thing on the declaration stack. So I'm going to say do I have a, yeah, I could say scope push decl. And so when we hit the return down here, that's going to automatically pop it because the destructor of this pops it off the stack. If it were my language, I would say push and then defer pop, possibly. Maybe not, because if you do it all the time, maybe you want this anyway. But it's just annoying if it's something you don't do that often to have to define this whole separate concept. Okay. Let's see if that parses, compiles, whatever. Yes, it does. So then, I guess the dependencies should happen automatically. So what's going to happen if I try to run this program, though? My theory about what happens is that it should parse this using correctly, and then it should get into type inference, and it should be like, I don't know what a using is. Why are you messing with me? Although, actually, remember this comment about this being kind of a hack? Actually, I'm returning a declaration, so I can return actually the declaration of that using, so I don't need my hack. Always good to clean up your hacks. Okay. So my theory is the code generator is going to say like internal error unhandled type. I don't know how to infer type for this thing. No, that's not even what it says. It says undeclared delta. Didn't even get that far. Undeclared delta. Oh, because it's parsing this, so anything it can fully do, it's going to do. So it's giving me an error in this line. Let's not do this line yet. Um, okay, I don't know why it didn't complain. It should have complained. It should have complained that it doesn't know how to infer a type for a using. Oh no, it shouldn't, because you know why? I'm not ever. All right. So in addition to creating this declaration, I need to add it to the scope. So I need to say add to scope interp current asked block decal. So if that's not in a scope, it'll never be encountered by the thing that walks the program to do type inference and stuff. Oh, I gotta recompile the compiler. Okay, well, oh, okay. So it hit a different safety check, which is if you're going to give me a declaration that doesn't have an identifier, you better have marked it that you meant to do that. Because if you didn't say you meant to do that, it might be a mistake. So that's what this assert says. And I did mean to do that, because when you're doing a using, it doesn't have an identifier. So declaration flags, declaration no identifier. Sometime later, when the system is more mature, and I have more like morale about that these data structures are all right and working, I might actually remove this safety, because it is a safety that just causes me to type more code and doesn't add any functionality. But you know, I've only been working on this for 5 weeks, right? This project was 0 lines of code 5 weeks ago, so it's good to have that kind of thing until you get your comfort. And that's still how I didn't recompile the compiler. See, if you don't do that, all right, there we go. That is what I expected to happen. Unknown expression type in inference. This is good. Just means we get to the next stage of the pipeline. So here we're going to add I'm going to do it before the directives. So I'm just going to say that a using infers to itself. Because, well, it'll infer to void, because we're not going to evaluate it as an expression ever. So we have this type def void, just for that kind of handy situation. So now, what should happen is we'll get to the bytecode generator, and the bytecode generator will say, I don't know what this is. Or it'll crash. Let's see why it crashed. It probably crashed because it doesn't know what it is. Oh, it's assuming the identifier is not null. Yeah. Well, okay. So we have a couple of cases where there are things with null identifiers. So like when you say hash run in some expression, it makes a top level function for that, and it doesn't put an identifier on it because there's no identifier that makes sense. But that is not a thing that actually generates code, right? So it never gets to this point. This is a point where we're trying to generate code that we're going to run. Now, using shouldn't get here anyway either. So I'm not going to try to fix this because there's not really anything to fix. What we want to do now, this is actually right where we want to be. We want to be at this point here. When we infer this type, it means that all the dependencies have been resolved, and we should be able to do whatever we want to do. So oh, I just realized, okay, this isn't going to work initially for more than one depth of using because the dependencies are going to be confused. Because you actually have to keep, you have to keep revisiting it. But for our initial test, we're only going to go one deep, and so that's an easier problem to solve. So we're just going to do that. So when we hit an asked using, we'll say apply using in as much as possible we'll say auto reinterpret cast asked using expression. All right, so I need to define this thing. Apply using it as much as possible. Whoops. Let's put that in the header file. Okay. Now I realize I never made that array of identifiers. So that is going to be the first thing to do. Yeah, I'm starting to get tired, so I'm going to try to make this work for the one depth case, and then go to bed, or I may go to bed even if I don't get there yet. Okay, let's. Do we still compile? Yeah. Okay. So let's go back to when we parsed this thing. So let's make sure now. When we parse a using, like I said, we're getting any expression. We haven't validated the expression, and we haven't set up our array of stuff. So I'm going to say while RHS if, well, I'll say, I'm going to rename it to something that's easier to go with, like an expression. Well, it's a dereference, I guess. While dereference, if dereference type is not equal to a binary operator. We're looking for binary operations, right? So we're, I wrote this thing, so we want to break down an expression like this. Linearize, validate, and linearize. That's the new name of this programming language. Interp report error attempt to use invalid expression within using. And the site where that happens is at dereference. And then we'll return null if that happens. Okay, so auto binary is reinterpret cast asked binary dereference. So if binary operator token type is not equal to dot, because we're only looking for dots, operator within using can only be dot. So this approach of parsing an expression that could be anything and then go piecing through it actually leads to generating better error messages, right? If you generated this code as like the output of a parser generator, and you said, well, it's some string of things with a dot, then it can just lead to the compiler being more confused about what's going on, right? I don't know. I think so. I suppose whether it's actually the error messages turn out better or not is sort of a case-by-case basis kind of a thing. So, But I feel like when I can parse a thing and then inspect it if it's wrong and tell people exactly why it's wrong, then that's better than some auto-generated thing. if only because I can drill in at whatever level of detail I want and supply more detailed errors. Okay, so the thing on the right hand of the dot should be an identifier. If binary right type is not equal to ident, within using expression to the right of dot must be an identifier. Return null. You end up typing in a lot of error messages in compilers. If it's a decent compiler. If it's not a decent compiler, you just like print out something cryptic and bail, and nobody ever knows what's happening. All right. So on the right, we have an ident. And on the left, we have a scope. So I'm going to say auto, scope expression is binary left, and auto ident is reinterpret cast ident binary right. Okay, so actually we don't even need to do this. So we say, what was our array called? Identifiers.add ident, and then dereference equals binary left. Okay, and I was wrong. So it doesn't have to be a binary, right? We could just do a using with a single identifier, right? So it is either an identifier or a binary expression with dot as the operator. If dereference type is equal to asked ident, do some things. Since it was not an ident, it must be a binary. All right. So if it's an ident, then we do this. And we break. Right, because there's nowhere to recurse. That seems kind of right to me, I guess. Wisdom of crowds, anyone have anything to say about this? Bueller? So the way it goes is just like, okay, so the way it goes for using is like this. You should be able to say using hello.delta. So you would read it as left to right, okay? But, I mean, imagine this was in like standard or something, right? The way that you want to resolve this is, or the way that the compiler organizes this is like standard.hello.delta, right? So you end up making a tree with delta on the right and standard.hello on the left, and then standard.hello has to get evaluated, right? So we're walking that tree and at breadth first, and putting the leaves on in a breadth first fashion, right? So the thing on the left ends up at the end of our identifier list, right? And so we want to pop the last thing off the identifier list and handle it. That's all. Was I born in 1988? No. I am using binary where it should not be binary. Why? Yeah, I don't want to hear arguments about how the syntax of the language is wrong, if that's what's happening in chat. While I'm trying to program, I can only pay so much attention to chat. There's an error in my code. Okay, what is it? Sir, or madam, as the case may be. I'm back at the code. There's a lag in Twitch, so wait, what? Okay. Yeah, there's a really long lag now. Copy and paste mistake. He's saying, okay, wait. Oh yeah, okay, here it is. Here it is. That wouldn't have compiled, so it's fine. Yep. Oh, and I, right. Asked using, right, is that what we called it? Yeah. I did that twice. Okay. So this still isn't going to work. It's still going to crash in the same place, I predict. Yeah. Because we're not actually handling, we're pushing these identifiers on, but we're not handling them yet. I just spilled tea all over myself. That's how late it is. Okay. See, that's why people watch these streams. You get entertaining moments like the time I accidentally dropped my cupcake on the floor, or the time when I spilled tea all over myself, or all that stuff. Okay. Well, let me take a kick at implementing this before I get tired and go home. So we're going to, so we apply using it as much as possible. And here's what we do. We say while asked using identifiers. Well, actually, let's go back here. And we'll say, so what if people say using semicolon, right? Like, maybe that should be an error, but maybe it's just a warning, because maybe if you're generating code, you might generate an empty using list or something, right? So I'm going to make a warning. Okay. So if asked using identifiers dot items is equal to 0, report warning empty using we don't return or something because we'll leave it, but whatever. Okay. So while we've got identifiers, we pop the identifier. Do I even have a pop method? I think I do. I want to say auto ident equals asked using identifiers pop. Let me see if that even dot pop. I should clean up these these warnings, if only because it'll make it easier to follow on the stream what the hell's going on. Oh, dot items. All right, so I do have a pop. I don't use it very often. That's why I don't know if I have it. If it's not resolved, it means we just couldn't resolve it. So if we got here, I don't even think we should get here. Like, we should never get to this code if an ident is not resolved. So we'll call this an internal compiler error. So report error asked using internal compiler error applying using but identifier is not resolved. Ident name return null. Okay, wait. What do we want to do? For now, I'm just doing a very limited version of this where we only import other scopes, right? Eventually, a version I want to do is to import a specific declaration from a scope, and that'll require an extra if statement here. But for now, it's going to be what type is it? Is it, remember the two types that we can reference into right now are, I forget what the types, the enumerators are called. So we have ask struct description and asked enum. That's a little inconsistent. Those should probably be called the same thing, but I'm not going to fix it now. I'm just going to let it annoy me until a later time at which I fix it. Break. So those are the two things we can using right now. And if it's not one of those, report error currently ident currently using can only pull in scopes from an enum or struct. Return. We don't return null because we don't have a return value. Okay. If it's a struct description, then oh, this is wrong. This is wrong. This is wrong. Okay. My mental model while I was first starting to type this was that, we pop the identifiers off and then we just keep pulling those scopes into whatever namespace we're in, but that's not what we want to do. If you go using a.b.c, you want to skip past a and b and like pull in c, right? It's beside the point because our first simple test case isn't even going to exercise this, but I want to hit it, I guess. So actually, no, you know what? Let's just make it work. Forget it. So I'm going to say, because I want to go home, incomplete if we are reaching through scopes as in a.b.c, then we want to make sure, what do we want to make sure? I'm completely spacing. That's how tired I am right now. We want to make sure of something. What I'm typing code. I'm a programmer. We want to resolve each subsequent identifier in the scope of our current block without requiring that identifier yet to be resolved. Oh, this is actually much easier than I thought. This is much easier. Okay. If you're using a.b.c, you only need to depend on a, because a will only be done when b and c are done, because b and c are contained within a. So if we get here at all, everything should be resolved. So I don't really need to worry about too much. In fact, it means I don't need this thing here. That can be local. I can say, okay, so okay, right now, yeah, right now we're not going to go down to leaves. We're just going to be in scope. So oh, but we need, okay, we need to store the scope that this is in so that we know where to put the definitions. So we're going to have to do that. Let's make sure we remember my enclosing scope. Current scope. All right, so we go down the identifiers. So we're going to do this resolution ourselves, except we're not initially for our test case, but eventually we are, because we want to resolve them in the subscopes ourselves. But for now, we're going to say auto resolved equals, this is the resolution that happens through the dependency system, right? Okay. So if the resolved is a struct, current scope equals